All right, 8-2 linear equations in two variables. Let's roll. All right, so we have linear equations as a thing of the day. What is a linear equation? It's definitely not an Evite partner offer. It is an equation in which variables appear in separate terms and neither variable contains an exponent. That's a big key there, is no exponents. Doesn't work that way. So it can be graphed by ordered pairs, or an equation resulting in ordered pairs. So like y equals 3x. I have two variables. Y equals mx plus b is another one, so there'd be numbers here. There's really only two variables there, but we'll get into that later. Another thing that I probably should have put on here is linear equations. Make a line. Because linear means line. So a nice way to think of that. All right, so solutions of linear equations are ordered pairs. So we're going to say, let's have this equation. Y equals negative x plus 8. So there's a four-step way to do this. It says, first you need to choose any convenient values for x. So usually somewhere around 0, because 0 makes life easy when it comes to substituting things in, because it just cancels out. So negative 1, 0, 1, 2, you might choose to do 0, 1, 2, 3, just whatever's convenient for you. Substitute the values for x. So you list your x values that you want to use. You put them into your equation here. So you substitute the values for all four. Yes, this is a lot of writing. Step 3, simplify your values to find the y. So we do negative 1 times negative 1 times negative 1 is positive 1. So 1 plus 8 is 9. 0 plus 8 is 8. Negative 1 plus 8 would be actually 8 minus 1 is 7. And you can kind of see a pattern by that point. And then you take the values, negative 1 and 9, and you put them in over here. So 0, 8, 1, and 7. So that would be a convenient numbers. And you just kind of got to pick them for that. So we'll review those again. Write the solution as ordered pairs. So let's review those. Step 1, choose any convenient values. So usually it's going to be anywhere between negative 3 through like positive 3. Anywhere in there, good numbers to pick. Substitute the values for x. So substitute whatever values you picked. And you're going to simplify and find those x values, or simplify to find the y values. And then you're going to write them as an ordered pair, which would be x, comma, y. Okay, so you could think of it like a machine. You pick your things and you input x in, which gives you an input it into the linear equation, and then it pops out as a y value. Then you just take the x and the y value, it's hard to see that circle I just made there, and you put them out as x, comma, y. Well, that's a fancy x there I just drew. All right, so find 4 solutions for this equation. So step 1, pick 4 things. So choose 4 values, substitute each value in. There may be many possible solutions, but we want to find ones that depend. The ones you find depends on which x values you choose. In this case, they pick 0 through 3. Those are convenient numbers. And they set it up with this kind of chart here. And this one, if I was actually making this myself, I'd probably make it a little wider. So we're going to input 0, 1, 2, 3, and 4. Write it in here. 0 substituted in for x gives me a y value of 3, and then I take 0, comma 3, and I put it over here. I input in 1 for x. Simplify that. 4 times 1 is 4, plus 3 is 7. So then I get 1, comma 7. I insert 2 in for x. 2 times 4 is 8, plus 3 is 11. 2, comma 11. Put in 3. 4, comma 3 is 12, plus 3 is 15. So the 4 possible solutions that we came up with are 0, 3, 1, 7, 2, 11, and 3, 15. Your try, go! All right, so I'm going to put the equation in right here. And we're just going to try the ones they did. So y equals 2, 0, minus 4. So that comes out to negative 4 because these cancel, which gives me a 0, negative 4. And let's try it again. 2 to the first, 2. So that's going to be 2 minus 4 gives me a negative 2. So that gives me 1 comma negative 2. I am seeing a pattern here. Y equals 2 to this. 2 times 2 minus 4. 2 times 2 is 4. Minus 4 is a 0. So that gives me 2 comma 0. And then y equals 2 times 3 minus 4 would give me 6 minus 4 is 2. So they give me 3 comma 2. So 4 possible solutions are these 4. And I'd have to actually write those out. So write them out like that. All right, at a local hardware store, a company, level 1 employees earn $48,000. Level 2 employees earn $24,000. Find 4 solutions of these two equals $216,000 to determine how many employees at each level they can hire for $216,000. So first we rewrite the equation by solving for y. So we take that equation that we came up with there that they gave us. We're going to subtract 48,000 from both sides. And then we're going to divide both sides by 20, or everything by 24,000. So it gives me y equals 9 minus 2x. So we choose 4 values for that and 4 values and substitute them in. So we substitute, and they chose 0 through 3. Perfectly good numbers, easy to do. Put in 0 first, gives me y equals 9, gives me 0, 9. So that'd be 9 minus 2, which would give me 7, so 1, 7. 9 minus 4, so it would be 5. And then 9 minus 6 would give me 3. And then I write the numbers 0, 9, 1, 7, 2, 5, and 3, 3. So a simple answer would be you can have 0 level 1s and 9 level 2s, 1 level 1, 7 level 2s, 3, and so on. All right. Cool. All right, at a local bookstore, hard books are sold for $6, paperbacks for $3. Bob wants to spend $42 on books. Find 4 solutions to determine how many books of each type he can buy. So I'm just going to call it X and Y, just to make life easy. So he can buy 6 books for X, plus 3 books of Y, equals 42. I'm going to reorganize this here, so minus 6x minus 6x gives me 3y equals 42 minus 6x. And divide by 3, divide by 3, divide by 3 gives me negative 2x. 42, this would be 10, 14 equals y. All right, so I need to find 4 values for this. So we can go 0, 1, 2, 3. Write it out here. So I'm going to take my thing here. I'm going to have 14 minus 2x. So if I put 14 minus 2 times 0, my y value would give me 14. So that would give me 0 comma 14. 14 minus 2 times 1. 14 minus 3 would give me 11. So it would be 1 comma 11. 14 minus 2 times 2. 14 minus 4 is 10. Wait, I think I messed something up here. 14 minus 2, 12. There we go. 10. 14 minus 2 times 3 would be 14 minus 6. So it would be 2 minus 2, 4, 6. Give me 8. So 2 comma 10 3, comma 8. So those would all be options. So I could have books. So $6 books, $6 books, 0, and then $3 books, 14, and then 1, 12, and then 2, 10, 3, 8. All right, graph this by plotting the ordered pairs. So first we need to find ordered pairs. Same basic concept here. So I find my x values. I pick 4 convenient ones. So we went -1 to +2. I can write those in here. Substitute in each time. Simplify this. -1 times 3 is -3. 0 minus 3 is -3. 1 minus -3 is 2. Put those together. So I come up with my ordered pairs, just like that. Now I'm going to go to the graph. So 4 solutions to this thing are these 4 ordered pairs. So I'm going to go to the graph. I'm going to plot those ordered pairs, draw a line through them. Note that the ordered pair for any point on this line is a solution of y equals -x plus 3. The line is the complete graph of the function. So it would look something like this. So you have to write all the numbers in here and draw a straight line, arrows on the ends. So it appears that the graph of 4, 1 is also a solution. Let's check that one by substitution. We're saying, so 1, 2, 3, 4, 1 appears to be a solution. Let's just check that by using substitution. So we take the equation that we had, we substitute in 1 and 4 for the x and y, comes out to 1 equals 1. This is a solution. All right, graph this one by plotting the ordered pairs. Go. All right, so I'm going to take my x value, and I'm going to go -1, 0, 1, 2. And my equation is 5 minus x. My y value after that, so 5 minus a minus 1 is going to be 4. And then 5 minus 0 is 5. And then 5 minus 1 is 4. Oh, that'd be 6. Negative, negative, positive. That's why that wasn't making sense. And then 5 minus 2 is 3. So that gives me a -1, comma 6, 0, comma 5, 1, comma 4, 2, comma 3. So that would give me those numbers right there when I put it into the graph. And that's all we have.